Hey everyone, thank you so much for joining and welcome to our Thought Leadership Series discussion, Are You Ready for 5G? Brought to you by Symphony Technology Solutions, Atlanta's leading smart building systems integrator. My name is Katie Galley, and I'm the social media marketing manager here at Symphony. Thank you all so much for tuning in today to learn more about 5G. And we just really can't wait to dive in. Before we start, want to give you guys a couple notes. So to stay up to date on all things Symphony, you can follow us on LinkedIn and Facebook at Symphony Technology Solutions and on Instagram at Symphony Tech Solutions. Furthermore, if you want to go back and listen to this presentation after we conclude today, head on over to our YouTube channel and subscribe to Symphony Technology Solutions. There at our, quote, Symphony Studio, you will be able to find our thought leadership content, as well as any episodes that will soon be coming out on our Technology Harmony podcast. Throughout the discussion today, if you have a question, we would love for you to write them in to ask of Eric. So just go into the chat feature on Zoom, hit the three little dots next to your name, raise your hand, and you can write in a question if you would like me to ask it for you, or if you would like to ask it of Eric directly, I will just unmute you so you can ask. As you will see, there will be so much great information on 5G coming your way today. And the best part is, of course, you will be able to revisit this entire talk on our YouTube channel, but we will also provide you the slide deck after the fact, so you'll have all the information at your disposal. All right, everyone, so let's get things going. To kick us off, I'll now turn things over to our president of Internet of Things Division, Trey Gaskins. Take it away, Trey.
All right, terrific. Hey, thanks for all that are joining today. We are delighted to have this series continue, and due to the COVID virus, we hope that you are doing as well as you can be during the situation. We were supposed to be at a golf course today, and with the rain, I'm glad we're not there today, but we're taking advantage of this new technology. You know, Symphony Technologies is a 35-year-old firm that's all things systems, low voltage integration. And we've been getting a lot of questions lately as it relates to 5G and what it means to our clients. You know, we service the whole spectrum of low voltage solutions from DAS and emergency radio responders, AV access control, GPON systems, fiber, your voice video data wiring. So we're here to help in that regard in any of those areas. But on 5G, a lot of folks have been asking, what does it mean and how do I prepare for it and how do I get my multifamily building or my hospitality or my commercial office building ready for 5G? And in this series, we've typically brought in subject matter experts, and today I am very proud to present my business partner, Eric Fickner, who's going to be talking to us about how to better understand 5G and really understand what it means to me, because it's a very confusing topic. So sit back, enjoy. We encourage you to ask questions, and feel free to raise your hand, as Katie mentioned, and we look forward to your comments and thoughts. And if you want to listen to this later and ask us questions later, you're welcome to as well. So with that, thank you so much, and we appreciate your joining us today. Katie, back to you.
Yep, really looking forward to diving in today, and when we turn it over to Eric, he will make his video available, so you guys will, of course, be able to see the slide deck as we run through it. And so, without further ado, here is Eric for Are You Ready for 5G? Hey, Eric.
Hey, Katie. Thanks for a great intro, and thanks, Trey, for calling me a friendly colleague instead of the names I deserve. But so I think we're going to go to the slide deck in a moment, Katie, or you want to, if you want to go ahead and start at we will share our screen.
Yep, absolutely. Yep, go ahead.
Yep, we're getting there. I'm not Avery Greer, by the way, neither was Trey, but we're all here in the same room, and it was determined that we wanted to avoid any contention, so we're all using one little screen and being very happy together. All right, so this is our presentation. You may notice it's a little different format than the PowerPoint. The youngsters here figured out a platform called Prezi that I quite like, so that's what we're going to use. It's effectively PowerPoint type format and content. And as Trey noted, we're talking about 5G from the perspective of a building owner or developer. So I'm not while I'll touch on aspects of the technology with respect to outdoors, what the wireless service providers, the WSPs do, and may say carriers, it's the same thing. It's really focused on what the implication is if you're a building owner. So let's get started. And I felt like to talk about 5G, you really had to make sure you had a base of 4G. 4G, of course, means fourth generation. Sometimes people are surprised at that, and even LTE just means long-term evolution. So those are not highly technical terms, but they get tossed around as acronyms, and you can feel a little intimidated. Obviously, that means we're in the current fourth iteration of a general technology collaborative that all of the worldwide carriers participated in. There are several standards bodies, and that the main technology used in 4G is LTE. There was a competing technology that Sprint tried to push forward called WiMAX. It doesn't perform as well, and you may notice that Sprint has bit the dust, and WiMAX failing to really deliver is a big part of the reason why. In 3G, you had competing technologies, and some of you may have heard the acronyms CDMA and GSM. So in 4G, you had the common platform, obviously after WiMAX finished, and that's LTE. In 5G, you'll have the same kind of thing. You'll have a common platform. There was an effort early on in 5G for Verizon to push a competing technology. That's since gone by the wayside. So with 4G and then 5G, what you have is a consistent standard around what technology platform will be used. That actually does create for better interoperability. You have the ability to get an unlocked phone and just drop in a card on it. In 4G and 5G, obviously you had significant improvements in speed and latency. Those are going to be the key those are key concepts to follow as you move into 5G. I think it's obvious to most people what those two words mean, but most people just think in terms of speed or overall throughput. But latency is as critical in the 5G transition, and so I just want to establish. So 4G, in a kind of a traditional sense over the past several years, has typically meant LTE technology operating in a frequency range of 700 to 2100 megahertz. I know there's a little bit of technology jargon, but it's important so you can see the transition to 5G. There's kind of a midway point, and you'll hear some people use the phrase 4G plus, and so you can kind of see the steps towards 5G. What the 4G architecture did was it took us not only to a new common platform, LTE, but you started seeing multiple in, multiple out MIMO versus just single in, single out SISO. So 2x2 MIMO, 4x4 MIMO. MIMO will increase significantly in the 5G world, like 128 MIMO, for example, in the millimeter wave. There's also some new licensing structure that's different in the 5G midband. That's a concept I'm going to introduce in just a minute. You now have to talk about low band, midband, and high band versus what with 4G was just a frequency range. I did want to point out to you, just for comparison's sake, because we will talk a little bit about other in-building wireless technologies. Wi-Fi operates at those two frequency ranges, 2400 and 5800, and has about a total amount of frequency available of 250 megahertz. Obviously, that's shared spectrum across any users because it's unlicensed. You'll see a few slides in the frequency range and the total amount of throughput that's available for the carriers. So that 4G plus that I mentioned. So in the past few years, you've seen T-Mobile introduce 600 megahertz, AT&T 2300 megahertz, Sprint 2600 megahertz. T-Mobile now owns Sprint. T-Mobile had initially talked about rolling 600 megahertz out as a 4G solution, and they're now talking, now that they have Sprint, counting 600, 2500 for 5G. If you've heard of FirstNet, it's not a commercial cellular solution, but it's an LTE broadband solution for public responders, and it matters because you're going to have to anticipate also allowing FirstNet propagation in your building. And then we mentioned Trey's our IoT president. Well, the impetus for a lot of 5G development has been the IoT, and I can make that really easy for you, Internet of Things, obviously, but I think it's really about, think of it as real-time machine-to-machine communication. And then if you structure that into multiple concatenations of different machine-to-machine communications into a whole workflow, That's really what Internet of Things is. So you effectively can connect anything, and you can create a workflow out of it and automate things. Okay, 5G. So all of those same frequencies that are now 4G, so you notice that 4G went from 700 to 2100 megahertz. Now with 4G, what I'm calling 4G plus, it went to 600 to 2600 megahertz. That's all now the low band of 5G. Now it's not all 5G yet, but that will be 5G low band. There's also a whole mid-band range, and then there's an entire high band range, and you'll see in a minute where those are. All of those bands will be utilized. Not every carrier has all the frequencies in all those bands, obviously, if they still purchase it. And the new technology that I mentioned is called NR, which just means new radio. Again, telecom people are funny for coming up with acronyms and making you think it's highly technical, and you realize it's just a word like new radio. So that's the technology that is really replacing LTE. Now, LTE won't go away completely. It is, now here's a good one, it is based on a method or a multiplexing method called OFDM. That is highly technical. If you want, I can get into it, but if you boil it down to why 5G becomes so much faster and so much lower in latency, it's because you're able to basically slice and put together multiple different slices, as it were, of bandwidth and frequency, put them all together and have them all communicating out and communicating back in rapid order. So, 4G had a theoretical maximum of 100 megabits per second. 5G will have a theoretical maximum of 10 gigabits per second. You can see you're talking about 2 orders of magnitude increase. The big thing is latency typically for 4G is somewhere in the 20 to 40 millisecond range, and the theoretical maximum latency in 5G is 4 milliseconds. So very rapid communication time. You start thinking about life safety issues and health issues and all of the different communication, data-rich video that relies upon no blips and bumps in that communication. That's what that low latency does. This is the slide that kind of shows you how spectrum is increasing. So you have the low band today. Across all of the carriers, the WSPs today, there's 650 megahertz of bandwidth. The mid band adds another 1850. You can see the high band then virtually doubles that. What that boils down to is you've got about 280% increase of mid-band spectrum and about 500% increase in the high band. But that doesn't really tell the whole story because what you get with those higher frequencies is just the physical nature of the waveform generates a whole lot more information a lot more rapidly. I mean, as you probably know, if you know any physics, those higher frequencies have smaller waveforms, and those smaller waveforms enable you to transmit more information more quickly. So it's not really very accurate to say, hey, it looks like about 800% more frequencies available. Yes, but it's the data carrying capability is about 10,000 times more. It's really about at that level. So the mid band includes what's called the Innovation Band, or CBRS, or as they've recently rebranded it, called the ONGO Alliance. So if you want to learn more about CBRS, that's the ONGO Alliance. Is probably the best thing to Google. And so the mid band includes that, but it's not just that. And then you have the high band, and that's the microwave. The mid band has some unusual licensing characteristics, that's what we mentioned, that are unique. And the high band is licensing similar to how it is now. So people think 5G is dangerous, and the reason why is because of the high band, because it's literal microwave. It is the same type of frequency that's being used in your microwave. And yes, you could sure cook someone like a frozen meal if you stood in front of a high-powered microwave transmitter. So you'll see that lovely little sign there. I've been up on rooftops and even towers, and it makes it very clear you don't want to walk in front of this thing, and it could be dangerous. And so there is that concern. Now, it's not ionizing radiation, so it's not X-rays, it's not gamma rays, like some people are concerned. So it's maybe you don't care about the distinction, but it's not radioactive. It's just excites your molecules, and that's how you cook in a microwave oven. The real issue is what would the power level be like at your phone? I didn't conduct these studies. I'm taking them at their word. the articles I've included for reference that you'll have available to you when you get access to this deck, they basically are non-scientific. They just sum up the scientific studies to say that, yeah, it looks like it's well below any dangerous levels. So it's not the big transmitter sitting up on top of the tower that people are worried about. It's the microwave being transmitted at your phone, and that's where all the studies have been occurring to try to verify that it's safe. And, you know, people have different conspiracy theories. Maybe you guys have some great ones you want to share with me. But in general, I think there's been a whole lot of study at a whole lot of different levels worldwide to verify that there's not any more inherent danger at the microwave level than there is at these low and mid-band levels. All right, so to sum up, 5G, now again, this hasn't been relevant to your building at all yet, but it becomes relevant, and you'll see why in just a minute. What is 5G? A whole lot more bandwidth and frequency, much lower latency, which allows for that real-time machine-to-machine communication. So as you hear people talking about virtual reality, artificial intelligence, it's not the computer can calculate much faster than a human. Now, computers can't perceive like a human. You know, you can tell a computer a joke all you want, or introduce metaphors, and it'll never figure it out. But the idea here with the latency is you have rapid machine-to-machine calculation that's faster than the human reflex. So that's where you'll start seeing. So you'll see it, you know, internally, like in your autonomous vehicle, but you'll also see it externally in the networks that control those autonomous vehicles. A huge increase in density, by the way. So with 5G, you have like 1,000 times more people packed in to a certain sector of space than you can with 4G. And of course, a whole lot more complexity. People are kind of asking about the timing for all this. Well, of course, we're seeing 5G now. 5G has already been deployed in 2019. Some would argue even in late 2018. Most predictions tell us that in 2 or 3 years, you'll mostly see 5G deployed in the urban areas. If you notice, T-Mobile, the CEO there, John Laguerre, just recently stepped down. He commented that 90% of America will never have 5G because he's known for making outrageous statements, and that's probably one of them. But it will probably take a whole lot longer in urban and non-dense areas to see 5G deployed. So you'll still see, what he meant by that were the mid and high band deployments. You'll see the carriers switch from the LTE, 4G LTE to the 5G NR technology across the board, probably in a 3 to 5 year time frame. I mentioned the machine-to-machine communications, and then I should just point out, part of what's involved in 5G is we have a new wireless carrier, Dish Wireless. So as part of the T-Mobile Sprint acquisition deal, Dish got some spectrum. They got the prepaid business of T-Mobile. Charlie Ergen already owned a whole bunch of spectrum. In fact, he was the largest private owner of spectrum in the world. And he's been getting a lot of pressure from the FCC to put it into use, and now he's going to. We know what frequencies they have. Part of what you've got to anticipate is if you're thinking about a 5G deployment now and in the future is to make sure that it will also be dish ready. I'm not even going to try to guess, how successful Dish will be, but there'll be a legitimate fourth carrier effectively replacing Sprint. But they will only roll out 5G, so they're not even going to start at 4G. They're only going to deploy 5G technology. All right, you can see I moved ahead to what about 5G in my building, and I felt like we have to really separate the low, mid, and high band technologies because it makes a real difference. You didn't have to do this in the 4G world. I mean, you had a range of frequencies, again, 7 to 2100 megahertz. They were all relatively available in your building if you had a building that didn't block the RF signal, or they all relatively weren't available. If you had a high, say a gold or platinum lead building, probably didn't get any cellular signal. So now it's different. So I'm going to tackle the low band and then the mid and the high band in separate slides. And so my first point is, if you're already getting good cell service in the low band now in 4G, you'll get good cell service with 5G low band when it switches to NR. The same frequencies, the same physical characteristics. Now, what you'll have to anticipate is if you have a DAS already or a booster, you'll probably have to replace the electronics. There are 1 or 2 manufacturers that are actually selling a 5G software upgradable 4G solution now. So if you were going to deploy today, you'll see my recommendation later. I would definitely deploy one that is software upgradable. It doesn't have to be forklifted. And then the people who make the decision about when it converts from the LTE to the NR technology will not be the building owners, it'll be the carriers. So at some point AT&T will operate, we don't know exactly what that transition plan looks like yet, but make up, at 2100 megahertz, they may operate LTE and NR in conjunction for a while in parallel, or they may just decide to turn down LTE one day and turn up NR the next. We don't know yet, but we'll see that conversion over the next 2 or 3 years. It'll happen, in different cities at different times, and they're all regionally controlled. Right now, you already see T-Mobile saying, hey, we're going to roll out 5G NR on their 600 and 2500 megahertz solutions. So that's where you'll start first, and then they'll go back to the traditional LTE frequencies. And so, again, roughly in 2 to 3 years, you'll see all of that roll out. If you're buying a cell phone now, it has 5G chipsets in it. In fact, the Samsung Galaxy, I think S20, only has you can't get it without 5G chipset. You don't have the option of only buying a 4G solution. And there will be some real increase in performance that comes with that transition to the new technology. You get better multiplexing. You'll see about 100 to 200% increase. Now, that's nothing when you think about the promises of a 10,000% increase that 5G is making. You get that by going to mid-band and high band. So as I pointed out, mid-band covers CBRS, which you see is in the 3,500 megahertz spectrum. By the way, Katie, I know, offered if anybody wants to interrupt and ask questions. I shouldn't use the word interrupt. I love taking questions midstream, so feel free to do so. You don't have to wait, but you're welcome to wait as well. So not all of the mid-band is currently available like CBRS, but this is a unique and unusual licensing structure. Some of you know about it, some of you don't, but it's effectively a certain bandwidth of frequency is going to be available to 3 different license holders all at the same time. So there's a complicated back end that goes around sensing which of the you have 3 different priority levels of who gets to use that signal, and then kind of how that all gets divided out. Plus, it's a shared spectrum between the different carriers, just that CBRS band. So unlike other frequencies that AT&T just owns this one particular band and Verizon owns that particular band, CBRS won't be owned by anybody. It'll be licensed first by the Navy, believe it or not, that's the primary license holder, and then by the carriers, and then which is just going to be called a general access license. That means you can operate a CBRS network in your building that is private. So it's a private LTE network. Some of you have heard of this, some of you are already anticipating it. What does that do for you? Well, I'll give it 2 examples. We have of course, COVID's interrupted everything, but we have a very large corporate client that has never been willing to put cameras, security cameras, surveillance cameras on a Wi-Fi network because of security reasons, but they are exploring putting it on a CBRS network. Now, that makes the possibility of adding those cameras in different places on a big campus environment a whole lot simpler. You still have to get power, but tying back to the network now becomes virtually trivial. The CBRS dongle today is maybe $50. And the second is we're working with a large gaming customer, and they've been wanting to be able to shift their gaming facilities to the games. And COVID actually has accelerated this to where, like, for example, they're talking about having slot machines that are 6 feet apart. Well, that mobility of being able to move the machines means they really would like to not have to wire their connectivity. And the Nevada Gaming Commission has never previously allowed any game to be on a Wi-Fi network, but they have approved CBRS. So you can see that CBRS LTE security significantly increase over Wi-Fi, which means that applications where you had concerns about putting it on Wi-Fi for various reasons, bandwidth constraints or security, are now alleviated in CBRS. That's the attraction of the CBRS network. It can be used by multiple parties, and the carriers will also use it, as I noted, because there are 3 levels of licensing, and we're actually working with some customers today who have some applications, like I mentioned, that are very excited about CBRS. And you'll see in just a minute, I'll talk about kind of, well, what if I tried to do both private and commercial cellular services on the CBRS network. So I'll cover that in just a moment. But here's a couple of use cases for what you could do. I gave you two, but you can see pretty much anything that you want to connect that you previously thought was the connectivity part was really difficult. We're working with a very posh country club in Florida, and they want to add cameras, and these cameras are 4,000 to 7,000 feet away from where their video management system for their surveillance is located. So you got to connect it to a network somewhere. They don't have any network connectivity. So they were looking at like trenching fiber for 7,000 feet, or using traditional point-to-point wired connections. And we're talking like we were pushing into the 7-figure range with both those solutions, whereas a CBRS solution is a low 6-figure range. So you're probably about an order of cost lower using CBRS than some of those traditional methods. Really anything like that. Okay, moving on to high band. So this is, I mentioned briefly, I didn't really cover it in the mid-band, but no mid-band signal nor high-band signal will penetrate from the outside to the inside. It's why, by the way, that you can have a 3-tier licensing structure with CBRS, because the AT&T can be using that signal outside the building to deliver cell phone calls, and inside your building, you can be using it for a whole different purpose, because the building envelope creates an effective barrier between the two. That just gets even worse in the high band. So the higher the frequency, you get more data capability, but you get less penetration of structure. In fact, you can block a microwave signal by walking in front of it. So supposedly I'm Avery here on this presentation, but if I'm broadcasting some microwave and Avery walks in front of it, and I was trying to broadcast to Trey, well, I just lost my signal while Avery meandered through our little walkway there, and that's how little propagation characteristics this has. So any kind of mid-band or high-band communications in your building will have to be done through a system. You'll never be able to have it just leach in from the outside like you can in some environments today with cellular. That's probably the biggest news with respect to a building owner. We'll talk a little bit about the implications of that and how to kind of plan for it. With the mid-band solution, especially the lower frequencies, the CBRS frequencies, there is a possibility to use the same network layer that you're currently using for 4G, so all you would have to do is add electronics. I'm not saying that that's true everywhere, but there are, for example, products today that are rated to all the way up to 3,600 megahertz. So you could potentially, if you're looking to the future, put in one network layer and cover all of the low band and some of the mid-band frequencies on one network layer, one infrastructure layer. That's not true for the high band. High band is going to all be fiber. It's all going to be remote, located out on the edge, and so you're going to have to put in an all new layer. So at the very least, you'd have to have 2 and possibly 3 network layers to accommodate the low, mid, and high band 5G in a building. I mentioned here that if you've done a fiber to the edge solution, either a 4G DAS that's fiber to the edge, or you're doing something like GPON, Symphony does a lot of GPON, for example, it may be beneficial to you. The problem is, I can't tell you, because the predictive models right now for 5G aren't even finally nailed down. So I don't know where those 5G remotes are going to have to go in your building. I have a pretty good idea, but I don't know exactly. And the software that models that doesn't have exact parameters for it. So it may or may not be helpful to you that you've got fiber to the edge because you got it on the wrong side of the hallway or whatever. I'm just telling you, it's not a guarantee. It's not a slam dunk. Now, here's the thing that should relieve your mind if you're thinking, oh my God, that's just so much cost I got to anticipate. It's very unlikely that you're going to do 5G in anything other than dense environments. So if you're looking at, let's say, a mixed-use environment where you've got a apartment high-rise, you've got a hotel, you've got commercial office space, I would venture to say in the next 10 years, you probably wouldn't overbuild more than 10 or 15% of that total footprint with the 5G millimeter wave, because you're just going to do it in the ballrooms and the meeting areas, and maybe you've got a food hall, although what that looks like after COVID, I don't know. But you're not going to be doing it on the residential hallways, where you have tenants or guests. staying, because there's just not a need for that kind of density and throughput and latency. You'll never be able to cost justify it. So you're only going to, in building, you're only going to overbuild 5G in those large common areas. Just for fun, I thought I'd tell you about propagation of 5G, because one of the big issues with the high band was people thought, well, if Avery can walk in front of my signal and block it, that's not going to be very effective. How's it going to work in a building? And these are basically the 5 different reasons why these last 5 bullets: millimeter wave, near line of sight reflectivity. I mentioned MIMO, 128. You went from 2 to 4. I've seen 8x8 MIMO once in my life, and we're going to be looking at 128 MIMO in 5G high band. I don't need to, you can read all of those. But what that amounts to is a surprisingly effective ability to propagate 5G millimeter wave inside a building. Better than a lot of people expected. And so there was a lot of skepticism for a long time. So you can see that kind of XS there at the bottom. That's the X is the location of the remote, and S obviously stands for source. You can see that by throwing a whole bunch of signal out and bouncing it around the room, it actually does penetrate pretty well. And I'm going to show you a real life solution here in just a second. But that's kind of a diagram that illustrates how a millimeter wave solution will actually cover an entire room. And then I'm going to show you, so there is one commercially available technology today, and this is an actual representation. So on the right, you have what the model predicted would be the coverage. And if you're not used to reading IV wave heat maps, you don't want dark blue. You're getting marginal with light blue. You love red, orange, yellow, and green. And so you can see the model predicted on the right very closely to the left. Those little dots are measuring actual. So to the right is the projected, to the left is the actual, and you can see you've got a few dark blue dots there over on the left side of that square, but really it propagates pretty well. And so you can see it, go back to the propagation map, if you see that red area, the little arrow and the little, it's like a splitter right there, that icon for a splitter, that's one remote. You can see if you put another remote up on the top left part of that room, you'd have great coverage. That's a 20,000 square foot room. Now, when people were first talking about microwave, they were talking about maybe 1,000 feet per remote. It would have been unbelievably expensive at that kind of density. You can see here, you're looking at maybe 10,000 feet per remote. Well, that's pretty good. That's pretty comparable to current DAS solutions. And so because of those 5 technology reasons that I listed before, that basically just thinking that signal is bouncing around everywhere. And if you bounce a whole bunch of those signals around, turns out you cover the whole room. Now, I will point out, now that I've passed that slide, we can't include that slide in this deck. That was a proprietary slide from the one manufacturer that actually has a commercially available 5G microwave solution. We were allowed to show it, but we're not allowed to give it to you. So it will be excluded from the deck. I apologize, but that was just the rules of the game. This stuff is brand new, and so they're guarding some of their proprietary technology. All right, now we get to kind of the rub. I initially had this titled, "Okay, my head hurts." Break it down. Katie felt like that wasn't great marketing. She probably knows better than I do. My head hurts, and I've been immersed in this stuff. But it's sort of boil it down to, I'm sitting with a building, either I have an existing building, I've got a building that's in construction, I've got a building in planning. Those are different profiles. What do I need to be thinking about? So I tried to kind of break that down into these different helpful pieces of information, and I think this is the rub for you. If you have 4G now, and it's coming in natively, you'll have 5G in the same frequency ranges. If you got an LED certified building, a LEED certified building that you're putting up, you're not going to have good signal. We just routinely see that that's the case. And of course, for the mid and high band, 5G will just make it a whole lot worse because you won't get any signal. A lot of people ask me about the cost, and we recently were working with a customer, and they said, hey, we've got your DAS bid, and we've got a competing DAS bid, and they're a lot lower than you are. That happens. I said, okay, that's fine. I gave you the technical specifications of what we're providing. what are they providing? They said, I didn't know, it just says DAS and then listed an amount. Then, I had to basically try to sort of sigh and think to myself, I know this is what's going to happen over the years, is people are going to take advantage of the fact that DAS, when it used to mean a sort of commonly defined thing, so you'll see the third bullet under cost. Today, if you were opening a building today, we'd recommend a 3-band SISO, single in, single out, 4G DAS solution, and we can do that all day for less than $1 a foot. There are unusual circumstances. You have an historic building, don't take it to mean everywhere, but real consistently, we're well under $1 a foot. Well, we're working on a very large airport solution right now. You may have heard of this airport, and it may be located close to our headquarters. And just in the low band, we're looking at 9 bands. So in that 600 to 2600 range, we're talking 9 bands in that, just in the low band range, and then adding mid band and high band. So we're explaining it's $1 a foot for a 3-band SISO solution, but you add 9 bands to the low band, and then you start adding mid band and high band. I mean, it's the sky's the limit. I don't know. We don't even know what things are going to cost in some respects. And so 8-10 years ago, people were paying a lot of money for DAS, and then it's dropped significantly. Well, it's going to go back up again. And what I'm going to suggest is, I don't think you necessarily want to go, oh, great, I got to allocate $5 or $10 a foot for DAS. I think that we're going to enter an environment where you have to be very careful and selective about knowing what you need and only taking what you need, and not trying to just pile on everything that the carriers would want you to have. So there's going to be a whole lot less ability to take 2 DAS quotes and assume that they're apples to apples. You're going to have to spend more time qualifying exactly what I'm getting. So imagine if you had a hotel and I said, hey, your audiovisual system is $150,000. Well, the first thing you'd ask me is, well, what does that include? How many TVs do I get? How big are they? How many rooms are you serving? What kind of control am I getting? You're going to have to do the same thing with DAS now. You have to ask a lot of questions. I don't anticipate a whole lot of subsidy going out from the carriers, from the WSPs, but I'll note as a counter argument that as part of the deal for getting Sprint, T-Mobile, and Dish Network now have a combined spend commitment to the FCC of $40 billion. They haven't said whether they'll spend it outdoor or indoor, so I don't know if it'll be available for buildings, but there's going to be a lot of money dropped on building out 5G in the next 3 years, and we're already talking with those carriers and working on prospective projects. So the possibility exists that there will be some money. It's going to typically be bigger projects. They call it over 1 million feet, 2,000 to 3,000 people moving through. And then the kind of last aspect of that I wanted to touch on, and this is a little bit technical, but it's one of the most difficult parts of DAS, is actually getting connection from the carriers. So there's some really cool technology development on that side. It is related to 5G. That's why I bring it up. So up until this point, you needed a very large, cumbersome, proprietary piece of equipment built either by Ericsson or Nokia. This year, carriers will start rolling out software-defined solutions that are a server in a rack. So not only will it become less expensive and easier to deploy, but you'll go from needing 6 or 8 racks for those, what are called base terminal stations, Nokia and Ericsson equipment, to 1 rack for all of your carriers, because they'll each have a 2 RU server, and that's all you'll need. So I'm real excited for the sake of my customers. It's going to be a lot easier to get carriers to now connect to your DAS, whatever your DAS looks like. All right, kind of to the last part. There's one quick little foray, and I don't want to take too long on this. Just wanted to mention other solutions in case you had any questions, and we'll kind of dive quickly through this. Basically, a lot of people think, well, I could just use Wi-Fi, and I list some of the challenges you have with Wi-Fi, and basically where we've seen it work, you've got to have these kind of qualifications. So residential, low occupancy, common authentication. So one network that not a lot of people use. Even then you have some limits. Now the limits will decrease over time as the two technologies, the Wi-Fi and the cellular LTE and 5G technologies kind of, partner together better. And there's a parallel to 5G in the Wi-Fi side that's called WiGig. I don't know if anybody's heard of WiGig, but you can anticipate that unlicensed spectrum that's available for wireless networks, for corporate networks or whatever, will be operating in the same microwave range that the carriers are going to. So WiGig will be a microwave technology. So I point out the upsides and the downsides of trying to use a Wi-Fi WiGig solution. And I'll just mention two things. One, most customers we see think that they're not competing, but they're combined technologies. There are different use cases and different applications. And then we are actually assisting some customers who tried to solve their connectivity solution with just Wi-Fi, and we're having to add a supplementary DAS because they've got some dissatisfaction in that regard. The reason I bring up the ERCS, Emergency Responder Radio Communication System, that's 17 syllables, a lot easier to say ERCS, is that in most jurisdictions, the fire marshal, the AHJ, will allow you to build on a common infrastructure. There are some places that won't. Denver, absolutely disallowed. Certain jurisdictions in Florida, disallowed. But in our experience, and we're into the hundreds across the country, we're over 30 states, the large majority of jurisdictions will allow you to build your DAS and your ERCS on the same cabling and antenna infrastructure, and that can produce a pretty significant savings. Now, where the trend is going, and the increasing survivability requirements, will that continue? I don't know. But right now, it exists as a good cost synergy, obviously more applicable in new construction. And the last thing kind of is, well, you mentioned that CBRS might be my holy grail, and it could be. CBRS might actually be a way to kind of solve all of your in-building connectivity needs, both private and cellular, for the next 5 to 8 years. The challenge is, because of the unusual licensing structure, there's not a current cost model for the cellular CBRS. So there's a cost model for private CBRS, and the carriers aren't even utilizing it yet because of the complexity around that cost model and all the back office solutions or technologies that are necessary to support it. But CBRS has the potential to enable you to get rid of two-way radios, to enable you to secure all kinds of various devices on a secure, bandwidth intensive, high throughput, high speed network, and for people to be able to walk in with a cell phone with a CBRS chipset and get 5G-like performance. So the potential exists, we just don't know enough yet. All right, now I get to the rub, which is some, if you will, some buying decisions. And this is really where we're going to wrap it up, and then hopefully have some good questions. But as I pointed out, today, if I'm opening a building today, we're saying for today, this is what you need. A 4-carrier DAS needs 3 bands. We typically do 700, 19, and 2100 megahertz. SISO, you don't really need MIMO unless you get a lot of density. And that works. It works great. And because in the past, you could pretty much say, all right, that's the standard. Everybody bid to that. You could kind of get a apples-to-apples comparison. Now, again, as I pointed out, have 9 bands just in that lower spectrum, plus the mid-band, plus the high band. So the complexity has hugely increased. You've got to really think through 4G today, upgrading to 5G. So you really want to find a solution that's software upgradable, so you're not, forklifting your equipment in a year or two. You really want to think about an infrastructure that might carry the low band and the mid band, and you got to be thinking about MIMO and at greater levels now. So here are our recommendations. We broke it down into 2 slides: new construction and existing construction. The first thing I'd say is whoever you're utilizing as your consultant or your integrator, they should have some ERCS, that's the public safety DAS experience, because they'll know whether you can converge the 2 networks into one and get about a 20-25% overall savings on the 2 systems. You also want to make sure that they've got good relationships with the carriers, because sometimes you can get money, and we've been working with T-Mobile a lot, and they got money to spend. So they're looking to take the lead on 2 projects we're working on, and they want to accommodate for 5G expansion. So they want to go ahead and build in some 5G now. And because the customer's kind of willing to do that, they're willing to put in extra money to actually pay for the in-building part. And then you want to make sure you can get the RF source at no cost, which is pretty likely. And then there's a whole lot of work around, well, exactly what frequencies are needed now and in the future. So you got to go through all of that. You want to make sure that you've got that, like I said, you've got a solution that's upgradable. You want to think about, if you're building a network layer, trying to have that network layer cover the low and the mid band. We think that you should very much consider, even if you don't want to buy a DAS, you think you're going to get signal from outside, at least putting the infrastructure in at a relatively low cost so that you're not surprised and then you have a whole bunch of disruption and delay because you got poor cell signal. That's why we suggest do the design, put the cabling in, especially if you can converge it with the ERCs at about 85% completion. Test it, see if you like how the cell signal is. And then you may possibly, because I said the propagation maps are kind of just becoming solidified, you might say, all right, look, I got a ballroom and there are going to be 1,200 people in there. I'd at least like to put in the cabling for that 5G solution that I'm going to add in 2 years. And that's actually possible like just now. It's only like just Q1 of this year is it viable to be able to do that. Existing construction doesn't vary much from new construction other than we don't really see an ability to, well, it might be the case, but generally speaking, I don't think you can converge with the ERCs. That's probably already been solved or decided. So otherwise, all the recommendations are the same. And I'm going to mention one kind of overall other considerations, and then I'll wrap it up. So I've mentioned CBRS a couple times. I think if you've got an environment where you have a lot of remote connectivity anticipated, especially if you think it's going to need to be mobile, that now is the right time to study whether a CBRS build isn't the right solution to kind of replace or combine a whole lot of your needs. The good thing is there are both Wi-Fi and DAS manufacturers for whom CBRS is effectively a sidecar add-on. So you can put in infrastructures now that would involve relatively little cost to add in CBRS. So that's one. I think the other thing is if you're thinking you want to just solve connectivity with Wi-Fi, I would strongly recommend you at least consider doing a preliminary DAS design and doing the cabling so that you're not doing what some of our customers are, which is we're scrambling and we're cutting holes in hard ceiling to get them signal now here right at the end. And then you should note, I think most of you know this, it's the number one reason why people choose a tenant environment, whether that's a apartment, a condo, a hotel, or a commercial, is location. But the number one reason why they unchoose or disqualify is cell service. They walk in, they walk around, they go, oh man, I love the 10-foot ceilings, this is great, but I got no bars. I can't live here. Sorry. And to wrap it up, yes, we'd like to help. Obviously, that's why we're doing this Thought Leader series. And I do actually mean that. We are more than happy to give you some advice if it never leads to a sale. The one thing I'm effectively the CTO here. The one thing I hate about technology is the way it's overpromised and underdelivered, or people use the complexity to somehow spin a big web and suck you in and make you feel like, I guess I'm stuck having to listen to this guy because I have no idea what he's talking about. So we really do love trying to help you clear through all the muddle and come up with a good, clean solution. So last slide, what's it boil down to? It is a much more complex world. As you can see, you're looking at so many different operating bands versus the few that used to exist in 5G and the costs that are associated with it and all the implications of in-building and out-of-building, the licensing structure. It's complex. So if you were confused about 5G, I hope I have dispelled some of that confusion, but I appreciate the confusion because I got a battle to keep it all organized in my head. I will say that, widespread adoption, from all I can tell, we're looking at 5 years. In 5 years, everybody will be on 5G. There'll be some expectation that you'll have the higher bandwidth than in the high band in your building, at least in the high density areas, and you should be sort of planning for that. We've mentioned some of the possibilities of cost synergies through converging with the ERCs, through using CBRS, eliminating two-way radios. You should look at that. and really think carefully about how to get cost synergies. And then finally, love Wi-Fi, do a ton of Wi-Fi. I'm very excited about the WiGig advances that we'll see in the next few years. Still think it's best considered as a complement rather than a competitor to DAS, and can give you a lot more reasons if you want to talk personally. I'm all done, and I think I'm going to turn it over to Katie and let her monitor questions if we have any.
Turning it back over to me. Well, Eric, thank you so much. And everyone, thank you all so much for tuning in. Yes, if you have any questions, of course, you guys can write them in now for the next couple of minutes. But two, if you have any after the fact that you would like to send to us, please, you can reach out to us on all our social channels. I'll go through those again. You can reach out to us on our website. We'd love to help you. So if you guys don't have any immediate questions, then I'll go ahead and wrap all of us up. So again, thank you all so much. Don't forget to follow us on LinkedIn and Facebook at Symphony Technology Solutions, and on our Instagram at Symphony Tech Solutions. Furthermore, again, if you want to go back and watch and listen to this presentation, you can head on over to our YouTube channel and subscribe at Symphony Technology Solutions. It will be available there in the next week, so you guys can watch the video, listen in, and again, that slide deck will be available to you as well. So here at Symphony, our ultimate goal is to make harmonious music out of all the technological noise. Thank you all so much for tuning in, and we will see you next time.